All right, the second half of today's lesson is going to be talking about parallel and perpendicular lines. And this is really just kind of an investigation of parallel and perpendicular. So I'm going to go through the notes for both this page and the second page. But again, your goal is to be able to at least identify whether the lines are parallel or perpendicular. So it says number 1, graph the following lines on the same coordinate. Plot at least 3 points and make sure your lines are very straight and accurate. So again, in order to plot a line, right, given an equation, we need our slope and our y-intercept. So this first one, our A, follows the formula y equals mx plus b. So in this case, we've got our m, which is 1/2. So we've got our rise, which is 1, and our run, which is 2. And then we have our y-intercept, which is -3. So let's go ahead and let's plot that line. So we've got -3 right here. And then we're going to rise 1, run 2. Rise 1, run 2. So we've got at least 3 points over here. You can go the other way if you want to. Down 1 over 2. Totally up to you. I'm just going to go ahead and draw this line over here. So this is my line A. Now I'm going to change my color and I'll do a blue. Now you may or may not have seen this second equation. This is actually called point slope equation. Point slope. It is on your formula chart and it looks like this. Now I know that that looks a little confusing, but what you really want to make sure you're paying attention to is this guy right here. That number, okay, also right here, is going to be your slope. So just by looking at the point slope form, it's going to be your slope because it's in front of the parentheses of your x. So we can go ahead and we can already list that over here. Your m is 1/2. So we're good to go on that. Now the second thing that we're going to need is going to be our y-intercept. Now in order for you to find the y-intercept, you're going to have to get rid of this 1 right here and make sure it goes to the other side because you're trying to get your y all by itself. So it's y equals, yeah? So to get rid of it, we're going to subtract 1. Now what we do to one side, we're going to have to do to the other side. It's not an option. You've got to leave it over there. Now we're not going to put it inside the parentheses. It's just going to be over on the side. Now the second thing that you're going to need to make sure you do is you're going to need to make sure you distribute that outside number to both of those terms inside the parentheses. So 1/2 times x is 1/2 x, and 1/2 times 4 is 2. So now we write our equation. Y equals 1/2 x plus 2 minus 1. Now the cool thing is, oh, that was weird. The cool thing is you can take these guys and you can add them together. So we end up with this. Y equals 1/2 x plus 1. Again, our slope is 1/2, and now we have our b, which is 1. So we come over here and we plot that. Oh, sorry, not a plus 1. Yes, plus 1, sorry, my brain. So we take it up 1 over 2. Up 1 over 2. We can go the other way. Down 1 over 2. Down 1 over 2. So here we go. Here's our second line, our B. Okay, last but not least, we have our standard form. Again, you're going to see this on your STAR test, so we're just going back over it. And it's going to look like this on your formula chart. So that's how we know it's in standard form. But the idea that we have to get y by itself is still not going to change. So let's go ahead and let's subtract our x from over here and place it over there. So we're now left with -2y equals -x minus 4. We divide by our -2 on both sides. This becomes a 1, and you're left with y equals a negative divided by negative is a positive. So we got our 1/2 x. A -4 divided by a -2 is going to be a positive 2. Our slope is 1/2. Our y-intercept is 2. So we come over here to our 2, and we go up 1 over 1. Or sorry, up 1 over 2. Up 1 over 2. Going the other way, down 1 over 2. And down 1 over 2. Okay, so taking a look at these, it says look at the 3 lines together. What types of lines have you graphed? Well, you have graphed parallel lines. Okay, then it says number 3, look at the graphs of each line and determine their slopes. So we've already determined their slopes. So looking at our graph A, we'll do red. We've got our 1/2. Looking graph B, also 1/2. And looking at our C, we have our 1/2 as well. Sorry, put that C up there. Now, what's the y-intercept of each line? Okay, well, our y-intercept of our C is 2. Our y-intercept that we have of our B is 1. And then our y-intercept of our A is -3. So then it says compare the slopes of the lines. What observations can you make about these slopes? Well, slopes of parallel lines are the same. Make a generalization about the slopes of any 2 parallel lines. Okay, well, again, that's a symbol for parallel. Parallel lines have the same rate of change. Using some different vocabulary. Number 7 says compare the y-intercepts. What observations can you make about the y-intercepts? Well, they're all different. Number 8, make a generalization about the y-intercepts of any 2 parallel lines. Well, think about this. If the y-intercepts were the same and their slopes were the same, then would they really be different lines? So we can say parallel lines have different y-intercepts. Number 9, explain what you think would happen if the lines had the same slope and y-intercept. Well, then they would be the same line. All right, let's take a look at our perpendicular lines. So let's take a look at A. Again, A is in slope-intercept form, so our slope is going to be this first set of numbers right next to the x, so our m equals 2/3. Our B is going to be this guy right here, so that's going to be our y-intercept. So let's graph this. So we're starting at over 0 up 2. We go up 2 over 3. Let's take it the opposite way. We go down 2 over 3. All right, and let's draw our line. Don't judge that. Oh, I gotta redraw it. Sorry, it's gonna bother me. Still bothering me, but it is what it is. Okay, cool. All right, let's take a look at our B. Now, if you notice, B, it has very similar numbers over here, so I wonder what's gonna happen with that. So let's subtract 3x over here. So we end up with 2y equals -3x plus 6. To get y by itself, we're going to divide by 2 on each side. So we're left with y equals -3 divided by 2 plus 3. Interesting. Okay, so let's graph this one. We're starting at a positive 3. This time, we're going to go down 3 over 2. So, knowing what we know about parallel lines, obviously these are not parallel lines. So, it says over here, it says, use a protractor to measure the angles created by the intersecting lines. Write the angle measure here. Well, here's what I want you to think about. Let's take a look at it, and I'm just going to draw this guy right here. So, filling in this shape right here, what type of triangle did we just create with that? Hopefully in your brain you were thinking, oh, well, Miss Hastings, that's a right triangle. And right triangles have 90-degree angles. So it says, what type of lines have you graphed? In other words, what do you call two intersecting lines that have a 90-degree angle for their measure? Okay, well, I hope in your brain you were thinking about the title of our notes today, and it says perpendicular lines. So we have created perpendicular lines. So perpendicular lines have 90-degree angles. So it says look at the graphs of each and determine their slopes. Well, the slope of my first one was 2/3. The slope of my second one was -3/2. So it says, what is the product of the two slopes? So if I were to come over here and take 2/3 and multiply it by -3 divided by 2, that means we would multiply the top two. So 2 times -3 is going to give you a -6. And then multiply the bottom, 3 times 2, it's going to give you a +6. So then -6 divided by 6 is going to give you -1. So the product of their two slopes of A and B is -1. Now it says compare the lines. What observations can you make about the slopes of the lines? Well, they're different, right? They are not the same. One is positive. And one is negative. Okay, also some people like to say the numbers are switched. So use the information you discovered to make two generalizations about the slopes of any two perpendicular lines. Okay, well here's the two generalizations we're going to make. First, their product is -1, but we really don't focus on that. Instead, we focus on this. Slopes are opposite reciprocals. So now what I want you to know about our reciprocals is if I have a 2 divided by a 3, then the reciprocal of that is 3 divided by 2. So they're just switched. That's what it means for our reciprocal. You're switching them. So we have two key components. It's going to take the opposite. So one is going to be positive, one is going to be negative. Then you're going to take the reciprocal, which means you're going to switch the numbers. Okay. So generalizations between parallel and perpendicular. Parallel lines have the same slope. Okay, parallel lines have the same slope, the same rate of change. Perpendicular lines do not have the same slope. They are opposite reciprocals of each other. So let's scroll it on down and let's take a look at this. This is identify a pair of lines, whether they're parallel, perpendicular, or neither. So I'm going to take a look at this guy, and I'm going to look at the slope. Boom, boom. Since the slopes are the same, these guys are parallel. Number 2. Okay, let's take a look at the slopes here. We got 1/5 and we've got -5. So this one's positive, this one's negative. Sweet, so we know it's not parallel. Now, if you look, we've got a 1/5 and we've got a 5/1. I know you're thinking to yourself, Miss Hastings, but there isn't a 1. Well, how would I make that 5 a fraction? You'd have to put it over 1. So are these right here reciprocals of each other? Yes, they are. Those are reciprocals. So we would say that these are perpendicular, and that is the symbol that we use for perpendicular. Number 3. All right, we got 3 and we got 1/3. Yes, you can take this and put it over. Yes, you've got your 1/3. Yes, those are reciprocals of each other. However, this one is positive and this one is positive. So because it's not opposite, we would say these are neither. Okay, number 4. Ooh, tough one. This is 3/4, and this is 6/8. So I wonder what 6/8 would be if we reduced it. So what if we divided by 2? So 6 divided by 2 would be 3, and 8 divided by 2 would be 4. Huh. So now that we've simplified our slope for the second one, and they're both going to have the same slope, then we would say that these are parallel. Again, your goal is to be able to look at your equations and identify if they are parallel, perpendicular, or neither. So this next one here is a tough one. You have your slope, which is a 1, and then you have your slope of this guy, which is -1. So let's go ahead and let's place them over 1. Now, are these reciprocals of each other? Yes, they are, because 1 divided by 1 is the same as 1 divided by 1. Now, if you look, this one is positive and this one is negative, so that satisfies our conditions for perpendicular, so we're going to say they're perpendicular. Number 6, one is positive and one is negative, but these are not reciprocals of each other. This bottom one would have to be 1 divided by 7, so we would say these are neither. All right, number 7, if you look at your slopes, oh look, they're the same. So we would say these are parallel. As long as they don't have the same y-intercept, we're good. And last but not least, our slope over here is -1 and -1, so we call this parallel. All right, I hope that you are good on parallel and perpendicular. Parallel have same slopes, perpendicular have opposite reciprocal slopes. This is what parallel lines look like, and these are what perpendicular lines look like. Your goal is to identify